Hello, this is Jeff Lumpkin from KenSci Analytics. I want to talk today about some data that we've been looking at, which comes from the National Center for Health Statistics, which is a division of the Center for Disease Control. In this instance, we're looking at a data set entitled Drug Poisoning Mortality by County. This is published annually by NCHS. In this case, the data set goes from 1999 through 2015. You can see here a choropleth map that has coloration by the mortality rate. I want to show you how we work with this data at KenSci. First thing I'm going to do is come to the export function and copy the link from CSV for Excel. Copy that link, and I'm going to come to Power BI and get data. I'll select getting data from the web, paste in this link, click OK, and this is going to establish a direct link to this NCHS website. And I'm going to edit this data before I bring it down into Power BI using Power Query. I'd like to explain the columns here. First, I have FIPS code. It's rendered this as numeric, and I'm going to change it back to a text code. So I'm going to change type back to text and replacing the current formatting. Now, the columns that I have here are years, starting in 1999, going out through 2015, the state name and the state abbreviation, the FIPS code for the state, a county, which is a concatenation of county and state, population, and then the key column, which is a age-adjusted death rate per 100,000 of population. So looking at the first row, this bucket is from 10.1 to 12 deaths per 100,000. The next row is 4.1 through 6. So essentially what we have here is a range. And to note is the fact that these values are left-oriented in the cell, which means they're text. This means that I can't use them as data, so I need to make some changes. I'm going to jump ahead and show you some of the work that I've done to make this data usable. First, I've created a column called min bucket, where I'm taking the left side of the estimated death rate, so you see 10.1. I've also created a max bucket where I have a value of 12. And then I've created an average, or it's splitting the difference between the min and the max. So we get 11.05 in the first row and 5.05 in the second row. So I'm going to take this as the mortality rate. To calculate fatalities then, I'm going to add a third column. So this will be a custom column. And I'm going to call this fatalities. And the formula will be the population divided by 100,000 times the mortality rate. When I click OK, we're going to see now a brand new column with fatalities. I'm going to change the type to whole number, and then I'm ready to take this data and bring it right down into Power BI Desktop proper. So when I hit close and apply, it's going to bring all 55,000 rows down into Power BI, and there I'm going to show you the type of analyses that I built up around this data set. So first thing, we'll just watch this table dropping in. So here's the table with all those rows that I've added. Now let me come to a more built out view. So we start out looking at 540,000 cumulative drug fatalities across that 16 years of data, with an average mortality rate for the same period of 15.5. You can see the mortality rate starts at 4.4 and increases out to 15.5 by the end. We have predicted fatalities, or I'm sorry, these are actual fatalities, starting in 1999 at 17,000 per year, running out in 2015 at 52,000 per year. I've broken out the U.S. into 6 regions. So we have the Northwest, the Southwest, the Central North and the Central South, the Northeast, and the Southeast. So if I select one of these regions, for instance, the Atlantic North, all this data is going to change to reflect the Atlantic North. And the Atlantic North looks to be pretty much on average for the country, not a lot of big differences in terms of mortality rate. One region that jumps out is the Atlantic South, where you see the mortality rate is 17.4, so above that 15.5. However, the region in the U.S. that has the highest average mortality rate is the Southwest, with a mortality rate of 20.7. When I look by state, one state also stands out, and this is the state of New Mexico, with a 2015 mortality rate of 26.2. If I want to drill in and look at New Mexico in more detail, I'm going to drill through to the state historical page. And this is where I'm looking at data for New Mexico. And what I see is by county, Rio Arriba County stands out as the county with the greatest mortality rate. When I select Rio Arriba County, this map is going to show me Rio Arriba County in the north part of New Mexico. And then we'll be able to look at the entire state and see mortality rates for all the counties within that state. And when I come back to the landing page, one thing I want to drill down to is some other counties that are in Appalachia. So when I select West Virginia, we're looking at data only related to West Virginia, and I see that we have a fairly high mortality rate in 2015 of 23.3. Now, I want to, let's say, take a look at a more detailed map. Let's go to the Choropleth map, where we're looking in 1999 at a fill map for every county in the United States. I'm going to select Appalachia, and we'll drill into just the Appalachian states. And the map itself is going to zoom down just to Appalachia. So here in 1999, there were no counties at a mortality rate greater than 30, but by the time we get to 2001, our first county in Appalachia is at that very high rate, and this turns out to be McDowell County in West Virginia. Now let's jump ahead to 2005, and you're going to see this red core spreading out, almost growing like a viral infection. So 2010, you can see it's quite widespread. And then by the time we get to the last year in the data set, 2015, this central core of Appalachia is really eaten up by very high rates of opioid mortalities. And in fact, a lot of these counties have hit the top bucket, which is 31 deaths per 100,000 or greater. And when I saw this, this concentration of counties at this very high mortality rate, I became interested in what happened to counties as they hit this mortality rate, or what was the course of hitting this high mortality rate. So I have a page called greater than 30. And when we look on this page, this is the number of counties which are at this very high mortality rate, greater than 31 deaths per 100,000. And in 2001, there were just 2 counties. When we jump ahead to 2005, it's doubled to 4 counties. To 2010, it's a 15-fold increase up to 33 counties. And by the time we get out to 2015, we're at 152 counties. Really huge number. And a couple metrics I created here. So this is the percentage of counties within a state that are greater than 31 deaths per 100,000. And you can see the overall average for the U.S. is 4.8. However, when we select New Mexico, fully half the counties are above this, or at this top level, and the overall mortality rate for the state is 26.2. Coming back to West Virginia, there are 17 counties at this very high rate. These are 31% of the counties in West Virginia. Similarly, when we look at Tennessee, we see a lot of states, 33 counties at this very elevated rate. And what's really frightening is how quickly states can go from 0 or no counties at the elevated rate to a super number. So, for instance, Tennessee went from 1 county in 2011 up to 15 counties in 2015. So this incredible growth. And this is really concerning to me. I wanted to get a better understanding of what this might look like if we did a forecast. So given how steep this curve is, if we wanted to forecast out from 2016 out to 2025, what might we be looking at in the United States? So I just used Excel to do a pretty basic forecast here. So here is my Excel file where I have the same columns that came from the CDC. And then I have one column for each year for population. So 1999 out through 2015. And then I have 9 years of growth data from 2016 through 2025, which is my population forecast. And this is just taking the 15-year CAGR, compound annual growth rate, from 99 out through 2015. I also have another set of columns for mortality rate starting in 1999, and again, actuals heading out through 2015. And then I have a forecast from 2016 out through 2025. And my forecast methodology was awfully simple. I looked at a 5-year CAGR, 5-year compound annual growth rate, and a 10-year compound annual growth rate, and then I took the minimum value of that of those two values. So in this first row, we're looking at a choice of 4.1 or 8.1 compound annual growth rate. This defaults to the 4.1 average. Similarly, the second row, the 10-year CAGR was lower than the 5-year CAGR, so we took the 2.7 value. Then I simply multiplied the 2015 rate times 1 plus the minimum compound annual growth rate, and I stopped if the resulting value was greater than 31. So 31 is the max value that we're looking at here. And then this became the basis for my forecast. So what does the forecast look like? Let's come back to Power BI Desktop, and we're going to start out just looking at the number of counties if we include the forecast. So I come up here to my period, and I select historical and now projected. And so now we're looking at data going all the way out through 2025, and let me maximize this for you. And so what we're going to see is this very sharp projection finishing out at almost 1,500 counties. Almost half the counties in the United States by 2025 are at this greater than 31 deaths per 100,000. And this seems a pretty fantastic number to have gone from 152 out to 1,491. Let me tell you why I have some confidence that this prediction has perhaps a bit of merit, and that is if I come and I change the y-axis from a linear scale to a log scale, what we're going to see is that my forecast is right in line with my prediction, and so or with the actuals. So you can see the actuals, this very straight line going from 2006, and just a very straight line out to 2015. My forecasted line continues straight out, and then through 2022, and then it flattens out. But for 7 years of my forecast, I'm right in line with what happened historically. Let me show you how this looks on a map. Now I'm using the ArcGIS Esri map here, and I just have a timeline where I'm going to show how counties increase. So now we're just looking at the actuals, meaning 99 through 2015, and there's one county in New Mexico, Rio Arriba County, and one county in West Virginia, McDowell County. When I click ahead, you're going to see these number of counties increasing. So now it's starting to grow in Appalachia, and that's about the only place. Now we see a county in Utah, a couple more in Colorado and New Mexico, but the real cluster here is in Appalachia. And so as we get out to the end of the actuals period, you can see it's spread across this band of the central U.S., but very much concentrated in New Mexico and in Appalachia. Now when I include projected, we're going to pop out a few more years. And so let's come out to our actuals. Okay, so this is the last year of actuals, and now we're going to get into our predicted values. And you can see at this point in time, virtually the whole U.S. is saturated. The area that remains the lowest is the upper Midwest, North Dakota, South Dakota, and Minnesota. But the rest of the United States appears to be very, very saturated with counties at this very high death rate. So I think what this means from stepping back from the data and just thinking about what this means for our country is we're a long ways away from turning around this problem we're having with opioids, and that while there is continued focus on this, I think that we need to think very carefully as a nation about how much effort and how much resources we're going to put against this problem to turn it around. Hope you found this interesting. Please feel free to contact me. My email is jeff@kensci.com. Thank you very much.